Bismillah ar-Rahman ar-Rahim. So look at this problem. This might not come in test number 1, but you have to think how to analyze forces and how could you find the reactions of pin at A and also the force of that nail inside the soil. So let's look at this problem. The bulkhead AD. So we have a bulkhead. This is A, D. It's to prevent the soil from falling down in the water. Just if you want to build a balcony here, if you want to build a house, you want to make the soil very strong to not to mix with the water. So the bulkhead AD is subjected to both water and soil. Water from the left, soil from the right. So there is a backfill pressure. Of course, there's pressure of the soil. Look at the pressure of the soil. And also there is pressure from the water. So there is, assuming AD is bent, so there is a pin here. Remember we were talking about in class, a pin here. A pin, you'll have reaction AY, you'll have reaction AX to the ground at A. Determine the horizontal and vertical reaction there. So you want to find out AY, AX. And also the required tension in the ground anchor. So this is an anchor, the bolting inside the soil. So we need to find out the force. How much force in this anchor here at the anchor BC necessary for equilibrium. We need to make not for the soil to fall and not for the water to get in the soil. So we need all of this, and the bulkhead has a mass. So this bulkhead AD has a mass of 800 kilograms. Let me just erase all of this to make it clear. Draw. Okay. So I will have a reaction here. AY. It's a bin again. It's not a fixed support. It's a bin. There is a reaction here, AX. And also there is a force from the anchor here. And it's mentioned here as force F. Okay. So let's look at the weight. Also, he has the weight of the bulkhead. The weight going to be at the center of that bulkhead, and it is down following gravity. And we know that the weight should be in Newton, 800 times 9.81 to convert it to Newton. Okay, so now what to do is to do a free body diagram. So we have to draw this first. So draw the free body diagram. We should draw the bulkhead and this side. Again, drawing a free body diagram will give you 5%. Not drawing it will give you -5, and plus you cannot solve the problem. You have to draw a free body diagram to understand how could you analyze for the forces. Now, we have a force, reaction force here, AY, and we have a reaction force here, AX. And you can see that this is a distributed load, and this load is triangle. So the base is 310, so it's 1/2 times 310 times the distance of this 6.5. So you can see we are going from here all the way there, so it's 6.5. So this is the force at this location from the soil on the bulkhead, 1/2, 310 times 6.5, and that is in kilonewton. Okay? Now, we have another force from the other side, from here, from the water on the bulkhead. So it is 1/2, let me see, this is 118. Yes, 118 times 4. So this is, well, we should know first before, because I want to know the directions. So this is 1/3 of 6.5. This is from the soil. It's 1/3 6.5. So 1/3 6.5, it is 2.167 meter. And the other force, it's 1/3 of a 4. 1/3 of a 4 is 1.33. So the other force because we need to know the location of these forces. The other force is 1/3 of 4, which is 1.333 meter. And then we could determine, or we could put the weight of that bulkhead, that 800 times 9.81, and that is 800. I put it here, yes, times 9.81. And that's 800 is in kilogram. So this is in Newton. You could notice that everything else is in, and we did this here, 1/2. And that is kilonewton. This has to be in kilonewton, so you should divide this by 1,000 to make it kilonewton. Okay, so now what else we have? We have the force at the anchor force BC. Let's just call it F. And this F is a distance 6 meters from point A. So now we have all these forces and we have all these dimensions, and we should start with taking a moment at A. Again, as we mentioned before, moment at A will cancel AX and AY. So taking moment at A equal to 0, and this is negative, will give you what is the first one, 1/2, and this is going to do a positive moment. 1/2, 310, 6.5 times 2.167, and then you have the other force here. That's going to be opposite negative. 1/2, 118 times 4, yes, times 4. It's not clear, it's 4 here. Times 1.33. So you have these two forces, and again you can notice that this force is not included because this is at the line of the action of that point. We include this force. This force produces a negative moment, minus F, times the distance from here to here. We mentioned it's 6 meters, equal to 0. Now we could find the force of the anchor. The force of the anchor is 311 kilonewton. So we found how much we will put the pulting or the anchor force in the soil to support the soil from falling. Now, we will do now summation of forces at X. We have the force F, and we have plus AX, and we have minus 1/2, 310 times 6.5. We have the other one, 1/2, 118 for AX minus this, plus this, and plus the force. That's equal to 0. And the force we know, this is 310. So you could find AX. Automatically, AX is 460 kilonewton. Now we will do the forces in the Y. We have AY, and you could notice there is nothing in the Y except the weight of the bulkhead. So AY minus 800 times 9.81 over 1,000 to make it kilonewton, equal to 0. AY is 7.85 kilonewton. Okay, I think this is more practical than anything else, and this is good for soil mechanic. This is good for fuel design in the future. A house in front of the ocean, a house in front of a lake, a house in front of a river. It's nice to account for the water pressure and also the soil pressure.